Hello, how's it going? Today I'm going to be going over the code that this video right here, um, the demonstration video, basically goes over. So this demonstration video I already uploaded. You can find it on my YouTube channel, Cody Raby. It's 15 minutes long. It showcases how everything works. This is going to be a comprehensive explanation of the code, how I made it. Basically, it's a fitness tracker that I built a RESTful API using Flask in the back end. And there's a front end for rendering the templates, obviously, that calls those API calls, databases, everything that built this app I'm going to be going over in this video here. So first of all, let's start by looking at the code, the structure for everything. This is going to be comprehensive. We have our basically our directory open. In our root directory we have a backend directory and a front end directory. And backend we have kind of the building blocks of what makes this code. Have our machine learning plan maker, which just uses a decision tree model that I trained on some data to generate plans for the users. We have tests, which have some basic system tests specifically for users, registration, stuff like that. Some of the basic endpoints. We have the app.py for the endpoints, also the middleware for validating the API key, and all of our endpoints here. And then we have our db creation.py. This creates our database. Databases, it's relational databases. And then we have email validator, which is really basic. This is just called at one point in the code to make sure that the emails are formatted as they should be expected to be. And then we have model.py for our databases, and predict.py, which is used for basically predicting what the decision tree generates for the lifts based on the user's input. So this is actually what does the predicting based on the decision tree model.pkl file, which is inside of right there. And we have our front end. Actually, we have this too. This is used. I'll get to this stuff in a little bit. It's not super important right now to just kind of go over it. But in the front end, we have our templates, static, which is style CSS, a function for unregistered users for calendar creation for display, config.py. I'm not going to open that, obviously. That's in the backend as well. And then a forms.py for login and registration. And there's also a reset form for if a user needs to reset their password. So yeah, I'm gonna go ahead and go over my feasibility documents first. So let me pull that up. Basically, this project is just a brainchild of mine. I have some experience working with Flask, so I decided to try to make the backend API, the front end, kind of do this all from scratch and segment it like that. But I also documented my plan for it and everything that should be done in a good project like that. So first of all, this is my functional requirements document. So we have for user registration, the system shall allow users to register for an account by providing this info, which is all how it works. User authentication, the system shall allow users to log in using their username and password. Calendar overview, the users logged in, the system shall display a calendar on the home page showing the days the user performed lifts. If no users logged in, it shall display a blank calendar highlighting the current day. Lift tracking, the system shall allow users to track their lifts by selecting a predefined lift or custom plan to load. Fill the set and reps with the weights and submit. This will update the lift performance table, which contains all of this info. It also contains recommended weight. So I actually added that as I was working on this. And then this is used for tracking the lift history, which in turn is used to make recommended weight, and that's why this is added there. And then we have plan creation. It'll allow users to create custom workout plans with ID, plan name, user-defined type of plan, like their little description of it, creation date, user ID, foreign key, duration, which is like the time they do it, and then our lifts. And then the plan table consists of this. Our plan lift table consists of this. And then we have goal-based plan generation. This is for our machine learning model. So the system shall provide the option to generate a generic workout plan based on a user-selected fitness goal, strength, hypertrophy, endurance, targeted areas. lift recommendation system. The system shall recommend weights for upcoming days based on performance data from the previous days in the same plan. So that's our recommended weight function. Lift progress update, so it'll automatically update the workout history with new lift data after the user tracks. That's pretty intuitive. And then a user-friendly design, basically allowing the users to manage their plans, and then advanced tracking history. So that's our functional requirement document, pretty basic. The work breakdown structure is here. So we have, which I need to, bam, bam, bam. We have, basically we start by researching competition, which I did. Our overview of how we're gonna do this, our pages. Database design, creating the database, setting up the endpoints, setting up tracking history settings, further front-end development, testing, deploying, pretty basic. And then we have our database design. This is just going over all the stuff that I kind of just showed in that other document. And I also should add recommended weight to this. And then we have our cardinality of our tables as well, right here. And then we have our EER, which is reverse engineered after it's all done. Users relate to plans. A user can have many plans. A plan can have many plan lifts. Plan lift can have many lift performances. And many plan lifts go to one lift. A lift goes to many lift performances. And users have many lift performances. So that's how it's logically set up in the EER document. And then we have our training data info. So this is how I made the training data. This is multiple now, because I decided to change that. So we have essentially the goal, hypertrophy or strength. We have the targeted areas, which are legs, chest, arms, back, or full body. 0 for no, 1 for yes. We basically get our info in the form of like 0 or 1 for the first one, 0 or 1 for the second one, 0 or 1 for the third, 0 or 1 for the fourth, 0 or 1 for the fifth, 0 or 1 for the sixth. And we take that, we give it to our prediction function, and then that uses that data to go through our decision tree model and decide what lifts the user can do. And I'm going to touch on that as well. That's how the data is created though. And this is our training data initial document, which we now have a huge one, which I'll show in the actual project. So that's our documents. It's pretty basic, but it's some of the feasibility stuff I set up before actually doing the project, and some of it while working on it. And then we have our README here. So this also links to all of the stuff. This is on the Git page, and we have kind of an explanation of some of the features and so on. So let's start by going over the database construction. So first of all, we have a function inside here. This is for creating our database that is ran. We import models, database lift. This is for populating the lift table because we have predefined lifts, which are all here with their info in JSON form. And we basically go ahead and we add a new lift to the table, like for all of the lifts here. Commit it, it does it. We do create all the tables and we populate the lifts with this function. And let's go over the tables that are being created. So you don't need datetime here anymore, so I can delete this. But in this file, see we have SQAlchemy import, bcrypt, and then we have this func import, which is for the basically getting the time that the account's created and other stuff's created. And we have our users class here. So in the users class, we have an ID, primary ID, username, which is unique, you can see here. And then we have the password hash, and then we have the first name, last name, email, creation date, which is set to the server default func now, which is the date, and then the date of birth the user inputs, and then we have the goal of the user, which is just their typed in goal. And we have the relationships here. Plans basically are related to the user through back reference, and if we were to delete a user, it would delete all of that user's plans because we have this cascade all delete orphan set up here. And we have the set password, which is just basically using bcrypt's generate password hash function. and it sets it. And we have the check password, which decrypts that to check against the model. And then we have our lift class here. You can see our relationship is with plan lifts. We only have a targeted area, a name, and an ID. Plan, same thing. Plan lifts is related to plan. And then we have our ID, our user ID foreign key. And then we have basically the plan name, plan type, the plan duration, creation date of a plan. Plan lift, you see here we have our primary key for that, our foreign key for the plan ID to this table, our lift ID, which is the foreign key to the lift that is in the plan lift, our sets, which is default to 3, but the user also can change that when they create, when they track their stuff. We have the reps, which is default to 10, and the user changes that as well. And then we have the back reference to the to itself, and then the cascade all. And then we have our lift performance table, which it back references to lift performances and to user. This one back references to lift performances, and then this one also back references to lift. We have our info here. This is the big one, right? So we have our primary ID for the lift performance, our foreign key for the plan lift ID, our lift ID, foreign key for the lift, our user ID, foreign key to the user. This one is connected to basically all the tables. The date, reps performed, tracked by the user. We perform, tracked by the user. Reps in reserve, which is tracked by the user. Recommended weight, which we get based on what the user puts so that they know what they should do in the future. And additional notes inputted by the user. So that's our database setup. And then the database creation.py, when this is ran, the way this all works is first you would go into the backend, you would do py db creation.py, run it. It would populate the lifts table after we create all the tables, and that would populate this, the fitnessapp.db. And then we would go ahead and we would do py app.py, and it would start running the backend, which we're going to go over now. So the backend is where all the juicy stuff is done. You see all our imports here. Basically, from here up is imports from Python libraries, JSONify, which we need because a lot of our stuff is through JSON objects. Requests we definitely need. bcrypt, load.env because of our API key and other information that we have locally in the config.py file. And then we have basically our setup stuff from our modules. So from modules, import the tables we all need, which is basically all of them. We have the recommend weight true math function, which I'll go over once we get to it, config, and then the email validator function from my module for that. So first we define our app, set it up, same way you do a normal Flask app. This is our middleware to make sure that all of the functions have the API key in the front end when they're called, to make sure that someone who actually has access to this API key is calling the functions. And then we basically into our endpoints. This is just a basic route. It's a little messed up, but it doesn't matter. And then our endpoints begin. So first of all, we have a getID endpoint, which right here, the getID endpoint, it takes API, getID, and the username and method of a string, and it's method get, so it's a get endpoint, and username is passed. So based off that username, we query the database user, which is imported from up here, for the username. And the first one that pops up, which a username is unique in our database. So if user and user ID, we return the user ID and 200, meaning success. Else, we will say not found 404 or user not found 404. So this handles all of the other instances, and this is a minor change so we know which one we're getting for debugging purposes. We have our get name endpoint, same thing, but it takes an int user ID, same method get. It's basically the same thing as this one, but through the user ID, and we check, and if it's right, we get the user's first name, and this is for display purposes on the front end. Delete, it's similar, so we have essentially the user / delete / user ID, method is delete, and it just gets the user in the session, so we have the user here, if the user, which would be there, found, we are going to go ahead and delete the user, commit it so the database does that, and return a 200. Otherwise, it's not found. And then we have an exception error catch as well, because we do a try and we need this to try. Then we have our endpoint for changing the user email. So this is just API/change email. This is probably the most basic, it's not basic I guess, but it's pretty basic. On the front end, we get the data from the object that the user types in, which is going to be their user ID and their new email. So if not new email, so the user does not put in a new email in the input, we're going to say no input found. If basically validating the email, validate email, this function is coming from email validator, import this. So this is a function for validate email. It's just making sure the format is correct. So basically what this is saying is if the email is not in the right format, then the email format is incorrect and we return a 400 error again. And then if a user already has existing user filter by email, basically meaning that the email the user is trying to change it to already is attached to a user's account, then we say a user with an existing email already exists, please try a different one, 409. And then we have user equals db session, get this, if the user is not found, meaning the user ID that was passed through is incorrect, we will return user not found. Otherwise, we get here where it is successful. So user email equals the new email, we commit that, and we return updated email, and we have our catch here. And that's basically it. And then we have this endpoint here for getting the track dates for the calendar. So if you remember, there's a logged in calendar view, and there's an unlogged in one. The logged in calendar view is what this endpoint is for. So we're going to go ahead and have a get method. It just is track dates, and we try user ID, getting the user ID from the basically from what is there, the year, the month. If we don't find the user ID, 400, user ID authentication error. If not year or not month, year and month are required, meaning that the calendar is unable to be populated. We get the track dates from the list performance.date part of the database, and we're going to go ahead and get all our info here and remove duplicate tracks, so that way we don't have any errors there. We get the unique dates through this, which basically prevents any issues with multiple trackings in the same date, and we return it in this form, and we return our dates in the track dates list, which the front end handles to display on the calendar. And we have our catch here basically, or our exception. And that's it for our basic user endpoints. So we have our authentication endpoints next on the back end. This is our register one. I'm going to start going a bit quicker because some of this stuff is basic. So first we get the data from the JSON that's passed in from the front end. We make sure that the data is correctly formatted. We look for the username, look for the email. We make sure that they don't already exist, is what this does. So the dot first. And then we create a new user with all of this info. We add it and we commit it. And then we do a successful message, which I should probably change that to 200, but it's 201. Then we have our exception here, where we basically log our error and then explain it's a server error, and bam. Over endpoint for login. This is going to take the data again. It's going to make sure that the information is there from the JSON object. It's going to look for the username, and it's going to check the password hash. If it's incorrect, invalid username or password, meaning that the username doesn't exist or the password is wrong. And then if it's right, we return login successful, user ID, username, 200. Then we have exception right here, just for other errors. This is our reset password endpoint. This one's also pretty basic. We get our data, we make sure that the desired password and email are entered in that JSON object, which is just a form. We look for the email, make sure that it exists. If not, then we say there's an invalid email. We check the password hash, or excuse me, we generate the new password based on what their desired password is for the change one. We set their password hash to their new password, commit it, and success. Then we have our exception here. And this is our endpoint for receiving user data for settings. So this will populate the user's page on settings where you, if you remember the video, which I recommend if you're watching this, you watch that before this because it will not make sense otherwise. The settings page consists of the first name, last name, username, all of this information displayed, and you can change the email and you can change a few other things on there and reset the password. So this is used for populating that, returns a JSON info, user info, and 200, otherwise 404, user not found. And that's it for those endpoints. We have our next set of endpoints, which is the plan creation and viewing endpoints. Plans is a post method type endpoint. We first do our try. We get the JSON data, make sure it's valid. If it is valid, we go here, get all of our information, lists in the form of a list. We make sure that the user and the plan are entered, and we create our new plan. This is basic. We just take our information entered from the user, add it to the database, create that new plan, and then we start adding the lifts to that plan. So we create a plan lift for each one of these lifts, and the lifts data JSON passed through, which is selected by the user. We set all of this here to default if the user hasn't typed one in, and then we go ahead and add it to the plan lift database, which has the foreign key plan ID here, which was just created. And then we commit that plan created successfully 201. Otherwise, we have our accept here. This is our retrieve plans endpoint. It's a get method, and this just gets all the plans for a user. We have the user ID. If not user, there's an error, the user's not been found. Otherwise, we go on. We get all of the plans through this plan query, query the plan database filtered by the user ID, and get all of the plans, which is what this .all does. Make sure that there are plans. No plans found for the user, we get this message. And if there are plans, and the reason we return this list is because there's in the front it is displayed through a list, so we need a list regardless, even if it's empty. And then we have here plans data. We start appending that information so that it can be displayed. And then that's it. We have our catches here, and that's it for that endpoint. This endpoint gets all of our existing lists. It just queries lifts.all, gets all lifts that exist. This is used for creating a plan, so the user can add the lifts to that plan that they need to add. And then we have our tracking endpoints here. So this is API slash, can that move? API slash plans, plan ID, lifts, lift ID track. So we need plan ID and we need lift ID, which you can see here. And this is a method type post. This is for tracking. So first we're gonna make sure that the plan exists that the user is trying to track. And then we're gonna make sure that the lift exists that the user is trying to track. And we're gonna move on, and we're going to go ahead and make sure that the plan lift exists in the plan lift database. And we're gonna get the user input. If the user does not input anything, meaning that the user types like nothing, tries to click next, then no input data is provided, we return this error. Otherwise, we move on and we get the user ID, the reps performed, the weight performed, reps in reserve, and additional notes for each lift. The recommended weight is done through true math, which that comes in play from right here. True math, right here, takes the weight performed and the reps in reserve from the user. If it's none, the true weight is 0, meaning that the new recommended weight is going to be 0. If it's not none, meaning we have that info, the recommended weight is calculate recommendation, which is this function, based on the weight performance and reps in reserve, which are passed in here. If the reps in reserve are less than 2, the recommended weight is going to be what the weight was performed, meaning that the user could barely do more than, basically they thought they could only do 2 reps max extra. So we recommend the same weight they did that time so that they don't push themselves too hard or get injured. If the reps in reserve is between 2 and 5, meaning they could have pushed for about 3 to 5 or 3 to 4 more reps, the recommended weight is going to be 5 higher. And then otherwise, it's going to be 10 higher, meaning that the weight was the user could do 5 or more reps extra. You return that recommended weight, which is right here. And then we're going to go ahead and round to the nearest fifth, making sure it's even, because at the gym, I don't know how often anyone watching this works out, but there's not really any 2.47 pound weights at the gym that you can slide on there. So we do it by 5s. So we round it, we print the true weight, return it, and that's how that works. So In this file, we get the recommended weight, and now we have all our info here, nice and pretty. And we validate the input, make sure it's all what we expect. Create our new lift performance record, where we make a new lift performance, add it to the database after setting all of it, and then commit it. And then return a success message, or if there's an error, this. Then we have our tracking data display for our endpoint. This basically gets all the tracking data for a specific lift and a plan, and makes sure that they both exist, gets all performances in order by descending date, puts them into JSON, returns a list of performance data for a front-end display. So basically what this is going to do is it's going to make sure the plan exists that the user passes in, because this takes plan ID and lift ID. Make sure that the plan lift exists, because we have plan ID, lift ID for the plan lift database to query it. And then we get our performances that are plan lifts of this type. Get them in descending order. Performance data right here, we get a list of it, list for perf and performances, meaning that for the performances in the performance data list, we're going to go ahead and add all of these to it. And then we return all of this data, and this is displayed in the tracking view for the user to see all of their previous lifts. And this is to get tracking data for a specific user endpoint. So basically what this is going to do right here is it's going to first do a try. It's a method get as well, you can see. So is that one. It's going to make sure that the user exists, which is passed in here. It's going to make sure that the plan exists, and then it's going to go through all of the for plan and plans, for plan lift and plan.lifts, for perf and perf. It's basically a triple embedded for loop. We're going to get basically every performance that the user has tracked. So for all of the plans, for all of the plan lifts in the plans, for all the performances based on that plan lift, we get this, which this can be changed to now, since I used to not have the fitness app. I used to not have some of the stuff set up in the models. So the user one used to not have access to some of these other ones, but this is how it works, and it still works now, so I think it's fine. And then we return our trackings, which is all of the user's tracked lifts, and then we have our accept block here. And keep in mind, this is all JSON data that is returned. This is all through JSON. This is a RESTful API. And then we get towards some of our endpoints. This is just getting all performance data for a specific user and lift. This is used for advanced analytics. So we have the lift. We get the lift by the lift name. We have the user ID as well passed in here. We query the lift database by name, get the first one. If not, the lift's not found. We get the performance data based on that user ID and the lift ID, so all performances of that lift, regardless of the plan, lift, any of that. If there hasn't been any, we return 205, that the user has no track logs of the specific lift. If it does, then we return this information, and we basically turn that in the JSON data. Return 200 success message. And then we get to the favorite endpoint, the generate plan endpoint. So this is using our decision tree. So I'm going to take some time to go over this one. We've got, first of all, our try right here that gets the data from the JSON. This is received from the front. If there's no information, invalid. We get the user ID, the goal, the body parts from the form. If not user ID, not goal, or not body parts, meaning that something's missing, basically we're going to say an error. And then since we got through all that, we are able to start generating our plan. So first of all, we need to decode what the users put in. So if body parts equals 1, plan name is going to equal the body part, and then this is an array, index 0, workout. So meaning like the user selects one workout in the front end. So I select back. This is going to say back workout. If it's 2, it's going to say back and arm workout, right? And then otherwise it just joins them, back, comma, arm, comma, and full body workout. And that's how that works. And then we go down here. We make sure that the plan doesn't already exist, meaning the user just spam creates back workouts, blah, 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 blah. It won't be able to keep doing that. It's going to say a plan already exists and not let them do that. Then we get our predictions, which this comes from our decision tree. So I can finally go over the decision tree. Notice what we need here is goal and body parts, right? Goal being basically the hypertrophy or strength, body parts being the selected body parts. So predict lifts, that comes from this predict.py. And then you can see in here, we have import pickle, OS, and then machine decision tree model, and pandas. So first we have our model path defined, our base directory defined, and our encoder path defined. And then we load our model, decision tree model, which let's go to that. So this is our decision tree.py file. You can see here, this uses sklearn.tree, decision tree classifier. This is a path that it's saved in. And we have our self init, initializing the decision tree classifier, our training based on the X and the target. And then we have our predict. This is used for our predictions based on the input data X, and then saving the model and loading the model. And then we have our train.py file right here. So this is for training the initial models, which are saved here, which we actually use those. And first we load our synthetic data, which is right here, which this is the huge data file. It's 1,000. I will go over how I made this too in a moment. But basically all we're going to do, where is it, train, is we're going to read that data path, load the data. We're going to have our X for the training data, our Y, our lifts, Y reps as our other target, and then we load the label encoder. We get the Y lifts encoded after using our label encoder for this right here. And then we go ahead, this is just for fitting it as well, the Y lifts. And then we combine the lifts and reps right here. We make sure our features are numeric, features, and we combine everything and drop any messed up value. Split and clean the data, which you need this. Train the model, train it based on our X and Y, target and input. And then we save it into our path, and that is really it for the train. And the way we made this file, which it's trained on, is here. So first of all, we connect to our database, which is fitnessapp.db. And here, if you remember that db populate, db creation.py, we populate all of this, right? So each one of these has an ID, they have a name, and then they have the targeted area. So we're using the targeted area for these predictions. So we're going to get targeted area from lifts data. So we have all the data. We have our different targeted area options. We loop through based on the lift name and targeted area, and we go ahead and append it. And then we're going to close that connection, so the database connection is closed. And then we generate random rep ranges based on our strength or hypertrophy selection. And then this generates synthetic data. It takes our number of samples, and then we do our data, which is going to be appended here. We do a for loop, so while we're working through the number of samples, we're going to randomly choose. The number of samples is inputted by us as well. We get to choose how much we want to do down here. But we loop through, and we randomly choose from our targeted area options in our database for basically for our plan. And then we're going to go ahead and set the rep based on the rep ranges goal. Get all of our lifts, all of our information, and then append it to our lifts list right here. So this makes sure that we have at least 6 and less than 9 exercises, and this makes sure that there's no duplicates because it is randomly selecting exercises from those targeted areas based on the user's targeted areas. So basically this just makes sure that there's no duplicates right here. If new lift, not in selected lifts, append selected lifts, add new lift. And then we go ahead and we get our rep range, which is just random for the rep min, rep max being rep ranges right here, those. We append to our record, and then we convert to a CSV file, and we have our synthetic data my underscore ff.csv created. And that's how this is created. And then we train based on this file rather than this initial really basic handmade one. And then we go ahead in the backend again, and we do predict lifts based on the goal and body parts, which runs the saved model, decision tree model, and gets us our input. So now that we have our predictions in the form of a list here, we create our new plan, default to 50. We add that plan to our database, and we add the lifts from the prediction to that plan, commit that, and then successful. Otherwise, we have our accept here. So that's it for our decision tree model and how that works. Then we have a remove existing plan endpoint. So this is delete plan. It's a method type post. And realistically, this could be type delete too. But anyways, first we get the info, the plan ID, and we go ahead and make sure that it exists or that it's been entered. We look for the plan in the database. If it's found, we delete it, commit, and that is really it. And then that's it. We go ahead and run this. Run it on port 5001, 000, so you can do it on mobile as well. And that's it for the backend. The backend, this is the bulk of it really right here. This touches on all of these. The data, the machine learning, plan maker, database, how the database is made, all of that. Yeah, so that's the backend. So the front end uses all of that to basically have the user be able to do what they need to do. What did I change here? Oh, deleted a line. Okay. So in the front end, let's check this out. So first of all, we have our static directory. It contains our styles.css, which I won't be going over. I'll briefly scroll through it, but it's just really basic styling, some colors, the width and stuff, making sure it's all formatted, at least basically correct. I didn't put too much effort into this as of now. We have our templates, so we have an about us file right here. Again, I'm going to show these right now, but I'm not going to come back to them. But about us is just a basic information page. There's nothing really too difficult in here, just HTML. Advanced tracking, you can see here we have our href to tracker, so you can go back to the tracker page from here. Form method post, so the user can select the lift that they want to see that calls that endpoint I talked about earlier. And it'll basically render all of the lifts regardless of the plan for the user, show any messages, and then display that performance data right here with all of these right here, which I'll get over in the app route, but I'm not going to come back to this HTML. Dashboard, you can see right here, this is going to get the user's first name, which is passed in from the front end, which I'll go over. The calendar month, so this is actually the HTML for displaying the track days in the calendar. You can see here we have like our for loop if statements inside the for loop for the track days, highlighting the track days, regular days as well. Buttons to go back to other pages that we need, because this is the user's dashboard once they're logged in, and that's it for that. Delete plan, pretty basic. The user basically selects a plan, for method type post, we roll for delete plan. It's going to go ahead and delete that plan, or give that information for the plan ID that we need to delete, referenced by the plan name, and then give us our message, and pretty basic. Generate plan, method type post, we basically let the user select all of the inputs for that decision tree model. You return that JSON data, pass it to the backend with the endpoint from the front end, get that data, and it basically generates it, redirects them to the plans page. Index, this is the guest homepage, user unlogged in homepage, whatever you want to call it. This basically uses our calendar creation.py right here. So this gets the current calendar, returns all calendar data we need, and is displayed on that page through calendar, month, the year. We have our class for our calendar days, Monday, Tuesday, Wednesday, Thursday, Friday, Sunday. Our for loop and else statements. Current days highlighted rather than the track days, and then that's really it. Otherwise, we have our login, register, and about us each references. Login, pretty basic. Form post, basically we get our username, password, and it's very basic. my plans, you can see this right here has all of these H references because on plans, this is kind of like a root directory for the tracker, for everything. It's kind of like a directory for that. So we make sure that the plan exists, or a plan exists. If plans, then we start looping through the plans and display them. And this handles all the logic for that through the embedded for loops and if statements. We have our Flask messages down here, and then otherwise we say no plans have been created if there is no plans, because this if plans does all this logic, otherwise there's no plans. This is for creating a plan. We have our method type post. The user inputs their plan name, their plan notes, the duration. They choose their exercises, this for loop between the range of 1 and 9. Select their exercise, their lift name, all of that. They set their sets, and then it ends the for loop. And once they click submit, basically that's going to create that plan through URL for plan. We have our register page. We have a H reference to the login page. Our flash messages here. Form post. Then we have all of our information for the registration, which I went over on the database. And then we basically submit that and we pass it for the registration endpoint. Reset password, pretty basic. H reference to login here. We have our form post. Form ends right here. This is our form. We basically are going to get the email from the user, their desired email, or desired password, I mean. And then once they submit it, we flash the messages based on what the backend says after the front end calls the backend endpoint. Then we have settings here, and this basically displays that performance data from the endpoint that I showed earlier. User's first name, which is passed from the front end. And then we have our buttons here so that the user can basically URL for settings, post. This is if the user wants to change their email. And then this right here is a link to the reset password page, which was right here, which I just went over. And then H references to dashboard and log out. Our tracker page just allows the user to track their workout plan. First, what we're going to do is let the user select the plan that they want to track. So this will do the tracker function, and if the plan is selected and matches as expected, we will get the plan and load the information. And then once the plan is selected, we display all of this and let the user track. So first, we have our table here. This is also a form, it's all inside a form. We have our table here with the lift, the average reps, the average weight performed. These are our table heads, by the way. Average reps in reserve, additional notes. That's displayed at the top, and then it loops through basically the different lifts on the left column and lets the user type in all of this information and submit it. Then we have our tracking history, pretty basic. This page gets a first name, blah, 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 tracking history, so Cody's tracking history if it's me. If trackings exist, meaning there's tracked basically workouts so far, then we're going to order them by date. We're going to style them, center them, and then we're going to show all this information for each one in a tracking entry div class. And then otherwise, no tracking info available. Then we have our H references. And that's it for the HTML. So now we can go over the actual, the juicy stuff, per se. So these are our imports. We have wraps, datetime, render template, redirect, session, URL for flash, request, Flask. And then these are from our custom stuff. So first we set up our app. We have our backend URL reference so that we can call our endpoints a lot easier. Our API key from our config file, and we have that API key in our header so that we can actually use our backend API, custom built RESTful API. So here we have our first function, get user ID. Basically, it's going to get the user ID in the session and return it. So this is just for ease of access to refactor some code. And this is to make sure users logged in. So it's going to basically wrap around each of the functions, and what it does is it makes sure that the user session has a user ID, and if not, it's going to redirect them to the login page. If the user is logged in, it lets them continue, and then it returns decorated function, which calls itself right here, and that's why this wraps is where it is. So we have our home page here. We basically just have /index generate calendar, which is from here. bam, which gets all the calendar info that we need. We get that info, display it. We also call get month name from here. And then we have our about us, just renders a template, about us.html. Our dashboard, first we get our user ID through that function, and then we go ahead and call our get name backend function, pass the headers so that we can actually call that. If you remember right, this simply gets the user's name, first name. If it's correct, then we're going to go ahead and get that JSON data, first name. If it's wrong, we're going to say it's an error in getting that. We get the date time, the year, the month. Then we're going to do this try, and we're going to call the track dates get function. Now that we have the user ID, the year, and the month, we pass the headers as well, and then we get the response data right here, which is just the track dates. We go ahead and format the track dates how we want by extracting the numbers. So this is what that dot day for day and track dates for loop. For the date and track dates, we do that, and then we have our accept here, and then we also have our calendar data, which we generate the dashboard calendar, which comes from here, which this simply gets the current date time, the year, the month, and then this OR is coming from the OR, where is it? Like these that are passed into it. And it basically just renders a template with the information needed to populate that calendar on the logged in dashboard. So this login page, first of all, we have form equals login form. That comes from forms.py. Login form simply basically validates that the data has been entered, the username and password, and then on submit, it's going to do login. So basically, we call that. We make sure that the login data is there. After it's validated, we pass that data to the login endpoint. If it returns success, meaning the user ID, the username and the password have been found and they're correct, we log them in and redirect them to the dashboard. Otherwise, we have an error. We render our template. We have our logout button. So this is, once the user clicks logout, it simply clears the session, logs them out, redirects them to login. And then we have our reset password right here. And you notice that these do not have login required like this one does, the dashboard, because we don't need to be logged in to reset the password, because that's also from the home page. You can do that. We get the reset form from this file right here, and we go ahead and we call the reset password endpoint if it's correct, and if it's 200 we redirect them to login. Otherwise we redirect them to reset password and they have to redo it, and we have our flash messages there coming from the backend, which we already went over. Register, same logic. We have our form, validate, call the register endpoint, and all of our catches. So if you're noticing a pattern, it's the same structure for all of these. Get the basic info we need from the inputs on the JSON data from the front end HTML, or display it by just simply calling that endpoint and doing like a user ID session get. So the settings page, you can see we get the user ID in the session. If the method type is post, meaning the user has selected like the change password or change email, then it's going to get the new email from the form, the user ID as well. It's going to make sure that the email doesn't already exist, or that the email, that the email has been entered, and redirect them to settings. So if the email has not been entered, it'll just reset them to settings. And then if it has been entered, we're going to call the change email, check our response codes, which I went over on the back end, explain what that means to the user, and then redirect them accordingly. Otherwise, meaning everything worked right, we tell them that it's been changed successfully, and they'll see it on screen. Then we get down here, and basically this is outside of the if statement. We come down here, and this default will get the user info by calling the settings user info endpoint, which I went over earlier. That simply gets all of that info about the user. So where is it? This side. User/info. Right there, right? So this just gets all the info for the user. And I could have been doing that for all of these, but I already went over the endpoints, so feel free to rewind to that part of the video if needed. Then we have our plan front-end rendered template. We get our user ID if the method is post, meaning they clicked on the create plan, and then get the information that they entered, their lifts that they selected, append them, put them in JSON data and payload, and we go ahead and pass that to our create plan endpoint. Create the plan, otherwise there's been an error. If there's a GET request, meaning the default of loading the page, we're going to go ahead and basically render the plan creation form through getting all of the lifts through the get lifts endpoint that gets all lifts. Make sure that that loads correctly, otherwise have no lifts load, and then render the template. Then we have my plans for showing the user's plans that currently exist. This simply returns response, user ID plans, gets all the plans. Get the user's first name for display purposes, make sure everything works as correctly expected. And then we load that information here in the render template, which is displayed on that HTML file I went over earlier. Delete plan, same logic, get and post, get the user ID, make sure they're logged in. If the method's post, meaning they selected a plan to delete, we basically call that and call this endpoint delete plan, the plan ID, and if successful, 200, otherwise the error and redirection to that same page. And then this gets all of the plans that the user can delete by default because it's the get, because this is if method type equals post. So this happens by default, this happens by default, this happens if the user specifically tries to delete their plan by selecting it and clicking it. Then we have our tracker app route right here. Gets the user ID. If the user selects something to track, we get the plan from the form. We go ahead and get the plans details with the user's ID plans endpoint. Get that JSON data. We go through the for loop of all of the plans so that the user can select a plan to track. We iterate over each of the lifts that are in that plan, allow the user to track them here. And then we go ahead and we try reps perform, reps and reserve additional notes, and then we make sure that everything's been entered as expected. Send the post to the basically the tracking endpoint with all the data, or each, because this is in this for loop, keep in mind, in the for loop, or each of those lifts, plan lifts essentially. And then we do this request post track URL, which is this, JSON, the payload, and then the header's API key. Make sure that it is as expected, tracking successful, and redirect the tracker. By default, we do this get, so this will go ahead and load our user's plans, JSON data for that, and then this will allow the user to select the plan and get the plan ID, and basically call that detailed information about that specific plan here with the user/user ID/plans endpoint. Get that JSON data, and then allow the user to see their selected plan info. Then we have our tracking app route, tracking history, excuse me. So this gets a user ID, calls the trackings, which gets all of the tracking history, and then just the username, like the user's first name for display purposes. Generate plan. This is simply going to default get the user ID. If the user clicks post, meaning they selected their goal and body part, so we make sure that they have selected at least a goal and at least one body part. We get that JSON data that they selected for the input, and then we're going to go ahead and call that generate plan, which uses a predict and everything else I went over, that endpoint. And then if successful, we've generated their plan, we redirect them to my plans, which shows them their plans, and they can see that. Otherwise, we have our error messages here, and we have our render template here. And then this is the last one for the front end. Basically the last thing code-wise that I'm going to go over, because that's really all that exists other than config.py, which I'm not going to open because the API key is in there. So in app.route advanced tracking, we have get and post methods. Basically we get the user ID, we get all of the lifts that exist, we get that lift info, and we're going to basically let the user select a lift. So by default, the lift name's none, the real record's none, max weight 0, and average weight 0, so that we can load this form here even if nothing is found. and then we're going to have a if request.method equals post, meaning they clicked the lift that they want to check. We get the lift name from this request.form.get. We make sure it exists, or that the lift has been selected, and then we're going to go ahead and call this user/user ID/lift/lift name/performance endpoint, where we get all of the performance records of that lift regardless of the plan, and we're going to go ahead and get their max weight through this max function, their maximum of the real record, and then the round we performed basically just getting the, I'm trying to remember how this works actually, because I did this a while ago. If real record L0, yeah, so this is just getting the average weight of all of the records of that specific lift. And then we have the max weight, which is just using the lambda, that's right. And then we have real record, which is just all of the information about that specific lift, like all of their previous trackings. So we pass that info here, render it, and then we have our app.run. So you have to run the backend first and the front end to have this work. I'm going to demonstrate it again now that I've gone over the endpoints. I'm going to cd into the backend. We're going to run that. Alright. Now we're going to run that. Localhost, so you can see the index page, right? Loads the default calendar. You know how that all works now. We're going to log in. We have our dashboard, right? So track dates, last time I tracked was on the 11th. We have settings, logout, tracking history, track workout, plans. Go to plans, you see my workouts here. I'm going to go ahead and remove one. Now that we know how this works. Bam, you see it's gone. I'm going to generate a plan. Say a chest and strength. That's down here. You have our information. We can go ahead and track a plan. The chest one. See how this all works now? We're going to say 10, 9, 9, 9, 9, 9. I'm going to say 100, 120, 60, 140, 143, why not? 40, 170. We're going to say 1 rep in reserve, 3, 6, 3, 0, 2. And we're going to say felt good, was strong, but hard, right? Something generic. And we're going to track that. So now we can go to the tracking history. We can see here our last track over here on the 11th, old one. We can see this track here, our additional notes right here, felt good, and then our recommended weight for each. So this recommends 125, recommends we go up to 60, recommends we go up to 148, recommends we go up to 170, recommends we go up nothing. Then we can view advanced tracking. We'll do dumbbell incline press. And we have our average weight here. We have our max weight we've done. And we have our tracked lifts, so we can see more info on that. And then we can go here. This is updated now. We can view our settings. See that we have all of my info here. I can change the email if I want. I can reset the password, so on and so forth. But that is essentially the program, the endpoints, the API, everything, how it all works. Hopefully it makes sense and that I structured this at least good enough for it to not be miserable to watch. I mean, it's kind of hard to go over how you make an endpoint and all this stuff, like while showing the front end and all of that. So hopefully it makes sense, and I recommend watching the first video first. It's a quick 15-minute of me basically going over this a bit more in depth. A lot less comprehensive, but more overview. It doesn't go over the feasibility documents, anything like that. Also, this is login, like this is register, this is login, basic pages, and the home page here. But hopefully that makes sense. For anyone watching this video, If you have any questions, feel free to leave a comment or to email me. My email is codyraby1@gmail.com. I do respond actively on there. And yeah, that's going to be it for my explanation of the Fitness Friend fitness tracker, custom built RESTful API, and front end Flask code. And hopefully y'all enjoyed. Have a good one. Take it easy, everyone. And yeah, bye bye.